relation defined as the collection of ordered pairs which contains an object from one set to another. There are four different ways to write a relation: ordered pairs, mapping, table, and graph. A function is a relation in which an element in the domain corresponds only one element in the range. And the trick to picking out the function is to pay attention to x. If all of the x coordinates are unique, then the relation is a function. If any of x coordinates repeat, then the relation is not a function. For example, find the numerical value if f of x is 2x plus 2 at f of 4. First, let us copy the given, then substitute the value of 4 in x. So f of 4 is equal to 2 times 4 plus 2. Then simplify. 2 times 4 is 8 plus 2 is equal to 10. Find the sum of f plus g if f of x is equal to 2x plus 3 and g of x is equal to 2x. So f plus g of x is equal to f of x plus g of x. So f of x is equal to 2x plus 3 and g of x is equal to 2x. Then simplify, combine the like terms. 2x plus 2x is equal to 4x. Then bring down 3. So the answer is 4x plus 3. For example, find the difference of f minus g if f of x is equal to 3x and g of x is equal to 2x plus 2. F minus g of x is equal to f of x minus g of x. F of x is 3x and g of x is 2x plus 2. Then distribute the sign. So 3x minus 2x minus 2. Then simplify, combine the like terms. 3x minus 2x is x and bring down 2. So the answer is x minus 2. Find the product of f times g if f of x is equal to 2x minus 3 and g of x is equal to 2x plus 3. F times g of x is equal to f of x times g of x. Then substitute the value. F of x is equal to 2x minus 3 times g of x is 2x plus 3. Then apply the FOIL method. 2x times 2x is equal to 4x squared. 2x times 3 is equal to 6x. Negative 3 times 2x is equal to negative x, 6x rather. Negative 3 times positive 3 is equal to negative 9. So, simplify. 4x squared plus 6x minus 6x minus 9. So, 4x squared, cancel the 6x minus 9. So, the answer is 4x squared minus 9. Find the quotient of f over g if f of x is equal to x plus 2 and g of x is equal to x squared plus 4x plus 4. F over g of x is equal to f of x over g of x. Then substitute the value. F of x is equal to x plus 2 over g of x is x squared plus 4x plus 4. Then factor the denominator. X plus 2 is over x plus 2 times x plus 2. Then divide the numerator by the denominator. X plus 2 divided by x plus 2 is equal to 1. So the answer is 1 over x plus 2. For example, find the product of negative 3h, where h of x is equal to 3x plus 3. Negative 3 times h of x is equal to negative 3 times h of x. Then substitute. the value of x. So negative 3, then h of x is equal to 3x plus 3. Then simplify. Negative 3 times 3x is equal to negative 9x. Then negative 3 times positive 3 is equal to negative 9. Therefore, the product of constant negative 3 in the function h is negative 9x minus 9. Given the two functions, f and g, the composition of f with g, denoted by f circle g, is defined by the equation f circle g of x is equal to f times g of x, wherein f is considered to be the dependent functions and g is considered to be the independent function. For example, given the function f of x is equal to 3x squared minus 2 and g of x is 5x, find f circle g. F circle g of x is equal to f, then replace the value of g. The value of f is equal to 3x squared minus 2. Then replace the value of g to x. So 3 times value of g, 5x squared minus 2. So apply the PEMDAS rule. First parenthesis 5x times 5x is equal to 25x squared. Then multiplication 3 times 25x squared, 75. Given on these examples, notice that the highest exponent of the variable x and y is 1. And if we are going to call the different types of algebraic expression according to the degree, we call an expression on the first degree as linear. And examine another example, y is equal to 5x cubed minus 3x plus 2. Since its highest exponent is 3, so we can say that it is not a linear function. In finding the zero of a function, we are trying to determine the value of x that could make the given function to be equal to 0 upon substituting. For example, find the zero of the function f of x is equal to negative x plus 9. So in order to find the zero of a function, first we are going to equate the given expression of the function of the zero. So negative x plus 9 is equal to 0. Then after that, we are going to solve the value of x and simplify. So negative x plus 9 is equal to 0. Transpose 9 here. So negative x is equal to negative 9. Then divide both sides by negative. So the answer is x is equal to 9. So for checking, f of x is equal to negative x plus 9. Then substitute our computed value of x, 9. So negative, then our computed value of x, 9, plus 9 is equal to 0. Since the resulting function is 0, we can say that our value of x here is correct. Graph of a linear functions. If you are going to graph a linear function, their graph is always a straight line. There can either be a diagonal line slanting downward going to the right or going to the left. Horizontal line is not considered to be a graph of a linear functions, but a graph of a constant function. At the same time, vertical line cannot be considered as graph of a linear function. If we can only consider a graph to be a graph of a function, if there is only one point of the intersection between the graph and the vertical line using the vertical line test. Two functions are inverse if and only if every domain of the function can be found on the range of the other, and vice versa, and their composition is always equal to x. For example, find the inverse function described by the set of ordered pairs 1 and 2, 3 and 4, and 5 and 6. In order to find the inverse of this set of ordered pairs, simplify, interchange the x and the y. So the x here is 1 and the y is 2. Its inverse is the x is 2 and the y is 1. Same here. 3 is x, 4 is y. Then the inverse is 4 is x and 3 is y. Then x is 5, y is 6. Then the inverse of it is 6x is x and 5 is y. So by examining the inverse of the given function, we can say that there is no existing common x coordinates. So we can say that it is an inverse function. So a quadratic function is a function defined by the equation y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c, where a and b are numerical coefficient of x, c is the constant, and the value of a is not equal to 0. In order to solve for the zeros of quadratic function, we are going to apply any of these three methods: the factoring, completing the squares, and by quadratic formula. For example, factoring: x squared plus 5x plus 6 factor. Its factor is x plus 2 and x plus 3. Then equate the following factors to 0. X plus 2 is equal to 0 and x plus 3 is equal to 0. So transpose 2 to the right side. So the sign will be changed. X is equal to negative 2. X plus 3 is equal to 0. Then transpose 3 to the right side. Then the answer is x is equal to negative 3. So the factor of x squared plus 5x plus 6 are negative 2 and negative 3. So this is the checking if the computed value of x is correct. First, copy the given. X squared plus 5x plus 6 is equal to 0. Then substitute the computed value of x to the given. So negative 2 squared plus 5 minus negative 2 plus 6 is equal to 0. Negative 2 times negative 2 is positive 4. Positive 5 times negative 2 is negative 10, then 6. So 4 minus 10 is equal to negative 6, and negative 6 plus 6 is equal to 0. Then x squared plus 5x plus 6 is equal to 0. Then substitute the computed value of x. Negative 3 squared plus 5 times negative 3 plus 6 is equal to 0. Negative 3 times negative 3 is positive 9. 5 times negative 3 is negative 15 plus 6. So positive 9 plus negative 15 is equal to negative 6 plus 6 is equal to 0. Since the result is equal to 0, we can say that our values of x is correct. To find the value of x using quadratic formula, x is equal to negative b plus minus square root of b squared minus 4ac over 2a. For example, the given is 2x squared plus 3x minus 2 is equal to 0. Then assign the value of a, b, and c. A is 2, b is 3, and c is negative 2. Then substitute the values to our formula. So negative 3 plus minus square root of 3 squared minus 4 times 2 times negative 2 over 2 times 2. So negative 3 plus minus 3 times 3, 9, negative 4 times 2, 8, negative 8 times negative 2 is positive 16 over 4. So negative 3 plus minus 9 plus 16 is square root of 25 over 4. So negative 3 plus minus Square root of 25 is 5 over 4. Then separate the different sign. Negative 3 plus 5 over 4 is equal to 2 over 4 divided by 2 is 1 half. Then negative 3 minus 5 is equal to 4. Negative 3 minus 5 is equal to negative 8 over 4. So negative 8 divided by 4 is equal to negative 2. So our value of x are 1 half and negative 2. A polynomial is a function defined by the equation y is equal to a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1, then a sub 1 x plus a sub 0, where a sub n is not equal to 0, exponents are whole numbers in a sub n and a sub n minus 1, and a sub 1 and a sub 0 are real numbers. In order to find the quotient of polynomial functions, we can use either of two methods, the long division method and the synthetic division method. So to get the quotient of a polynomials, we can use long division method. So for example, divide x squared plus 9x plus 20 by x plus 5. So the divisor is x plus 5 and the dividend is x squared plus 9x plus 20. First, we must divide the first term of the dividend to the first term of the divisor. So x squared divided by x is x. So x times x is equal to x squared. And x times 5 is equal to 5x. Then subtract x squared minus x squared is 0. Then 9x minus 5x is 4x. Then bring down 20. Then divide 4x divided by x is equal to 4. 4 times x is 4x. Then 4 times 5 is 20. Then subtraction, 4 minus 4x is equal to 0. Then 20 minus 20 is 0. Since the answer is 0, there is no remainder. And we can say that when you divide x squared plus 9x plus 20 by 5 by x plus 5, the answer is x plus 4. So another way of solving the quotient of a polynomial, the synthetic division method. First, copy the given. Divide x cubed minus 2x squared minus 5x plus 6 by x minus 3. First, we must write the numerical coefficient of the dividend. So 1, negative 2, negative 5, and 6. Then on the right side of the row, you must get the inverse of the constant of the divisor. So in this case, we must equate it to 0. So x minus 3 is equal to 0. So x is equal to 3. Then first, bring down the first term. Then multiply it by 3. So 1 times 3 is 3. Then add negative 2 plus 3 is positive 1. Then multiply 1 times 3 is 3. Then negative 5 plus 3 is negative 2. So negative 2 times 3 is negative 6. Positive 6 minus 6 is equal to 0. So to get the literal coefficient in their degree, just subtract 1 from the highest degree and affix then with a constant arranged in descending order. So the answer is subtract 1 here. So x squared plus x